All right, so the focus of this lesson is similar to the previous one. The only difference is we're going to find the area using what is called a midpoint Riemann sum. So what we're going to do is, like before, we're going to divide it into 4 sections. So we're going to partition it. So we have 4 sections, and let's pretend those are equal width. So here we have 1/4, 2/4, and 3/4. And what we're going to do this time that's a little different than last is we're actually going to find the middle of each of these segments. So for example, the middle of 0 and 1/4 is going to be 1/8. And we're going to locate that middle. Give me 1 second to fix this. We're going to locate that middle. It lets me. And we are going to create our rectangle through that middle point. And then we're going to do the same between 1/4 and 1/2. So we are at 3/8. It does not like me writing this small. So let's try that one more time. We are at 3/8. And then here we are going to make our rectangle. And then we are at 5/8, which is right here. And we are going to make our rectangle. And then we are at 7/8, which is here. Sorry about that. My computer does not want to stay on the same screen. I think it's really the size and location of this. So I'm actually going to move this up and go back. We'll share this one more time. So like I was saying, we are cutting this into those 4 sections, our 1/4, 1/2, our 3/4, but then we are dividing it into the middle, right? So the midpoint of that section, which we had said was located at 1/8, and in this case, because our function is squared, it's 1/8 squared. And then between 1/4 and 1/2 is a 3/8. Cut right through there, and that there is 3/8 squared. And then here we're going to go through the midpoint, which is 5/8. So that's our 5/8 squared. And then our 7/8, just right here. And we have our 7/8 squared. Now remember, the objective of writing these is to come up with a formula that allows us to approximate the area under the curve. And so in this case, we're going to have our M4, our midpoint Riemann sum, 4 partitions, is going to be our width, which is still 1/4 like yesterday, but our heights are a little bit different. We have our 1/8 squared and our 1/4 times our 3/8 squared, our 1/4 times our 5/8 squared, and our 1/4 times our 7/8 squared. And then from here, simply typing it into your graphing calculator or into, say, Desmos, we can quickly get a value for it, right? So we had 1/4 times 1/8 squared, 1/4 times our 3/8 squared, plus our 1/4 times our 5/8 squared, and then last but not least, our 1/4 times our 7/8 squared. And we could see that we get a value of 0.328125. So this is equal to 0.32, and I lost that really quickly, 8125. 8125. And you'll notice that this comes out much closer to the actual. If you remember from yesterday, our actual is 1/3 for the area between 0 to 1 under x squared. And this is really quite close to that. And really the reason it comes out so close is you'll notice, if you look closely, that the amount it's over and the amount it's under for each of these kind of cancels each other out. And so it comes out close to the actual. All right. Now what we're going to do is we're going to take a look at this again, but this time we're going to do what is called a trapezoidal. Now, a trapezoidal area is going to cut this into trapezoids. So what I'm going to do is, once again, I'm going to partition this. But this time, what I'm going to do is I'm going to cut it into trapezoids by connecting the endpoints between these. So I'm creating kind of these trapezoidal shapes. And what I'm going to notice, if I remember from middle school and elementary school, that the area of a trapezoid is equal to 1/2 the width times our two heights, height 1 and height 2. So if we look here, we have our 1/4, 0, our 1/2, and our 3/4. And our heights are going to be 0 squared, 1/4 squared, 1/2 squared, and 3/4 squared, and then of course 1 squared. And we're going to be finding the area of each of those and combining them. And we're doing what's called T sub 4. So you'll notice that every single one of these will have a 1/2 times our width, which is 1/4. And so what we're going to do is actually just pull out that 1/2 times 1/4 instead of rewriting it over and over. Our first trapezoid will have 0 squared plus 1/4 squared. Our next trapezoid will be 1/4 squared plus 1/2 squared. All right, and then we have 1/2 squared plus 3/4 squared. And then lastly, 3/4 squared plus 1 squared. And let's close this. And so before we type this in the calculator, let's just simplify it a little bit. So this is 1/8. Here we have 0 plus 1 over 16 plus 1 over 16 plus 1 over 4. I'm just going through and expanding each of these, squaring them. 1 over 4, 9 over 16, 9 over 16, and then 1. And if I look closely, I'll notice that there's a whole bunch of 16ths. So I'm going to actually jump up here. So I have 1/8, and then I have 1/16, 1/16, 9/16, 9/16. So I actually have 20 16ths. And then I have 1/4 and 1/4. So I have 2/4 and 1 whole. So let's jump back to Desmos. And I had 1/4. So 1/2 times 1/4 times my 20 16ths plus my 2/4 plus my 1 whole. And I can see that the area under the curve is approximately 0.34375. So 0.34375, which is actually slightly less accurate than the midpoint one. And that's it.